All right, our second part of constructions, establishing bisectors. We're going to be looking at both bisecting of segments or distance and bisection of an angle or degree measure. Let's start with the segment. Very simple construction, very easy to do. So you can kind of see that roughly right about halfway between A and B we have a midpoint. What we want to construct though is a perpendicular bisector, which means we need to construct a line segment or line that will go through that point. So that's what the compass is going to help us define. Very simple. First, get your compass and have a setting so that when you place the metal point on one of the endpoints, that the distance to the pencil point is beyond halfway. You can kind of eyeball what it is. Some people, what they like to do to make sure is they go out a little bit further. But I like to be just a little bit, not too far. So your choice. Then draw an arc, like so. And very important, do not change the setting. Place the metal point on the other endpoint. Draw the same arc. You should then get two intersection points. One above and one below. Those are 2 points of reference I can use to construct a line. So let's get our straight edge. Line up the two intersection points. Draw a nice line through there. If you want to, you can put arrowheads on it to make it a line. And if you notice, it appears that this line has cut segment AB in half. So I'm going to label that point M, M for midpoint. And it's also perpendicular, so I can put a little square there, which identifies the fact I've established a right angle. There's a lot of stuff that happened in this construction. So I can now write the following statement. The measure of segment AM is now equal to the measure of segment MB. Also, we of course can now say that segment AM is congruent to segment MB. Let's label the line L. We also know that line L is perpendicular to segment AB. And you can definitely see that at point M we've established a right angle. Pretty simple construction, something you'll need to practice. Notice the two arcs establishing two intersection points. Remember that the metal point is placed at one of the endpoints first with a compass setting beyond the halfway point. And it's very easy for you to eyeball that and use that to your advantage. So enjoy, keep practicing. Let's now do the angle bisector. I have two angles here, so we can practice it. It's a fast construction. Again, an angle bisector now, what we want to do is we want to cut in half the degree measure. We're not cutting sides in half. We are going to find a ray that will find a place that cuts the angle in half. So to do that, we need to find a point of reference somewhere out here, somewhere along this ray, so that I can, with the point at the vertex, draw that ray with confidence. So, let's get our compass. Let's choose a setting not too big, not too small. And very simple. Draw an arc so that it intersects both sides, like we did with our duplication process. But this time now, we keep our compass. We now move to one of those endpoints, one of those intersection points. We draw an arc in the interior of the angle. Very important now, do not change the setting. That's why it's important to have a good compass. Metal point at the other intersection, carefully. Draw another arc so that you establish a point of intersection between our two arcs. That is the point that I will now use with my straight edge to construct the angle bisector. Line up that intersection with your vertex and very carefully draw that. Very nice. I'll put an arrowhead on it, making a nice little ray. We'll label this as point D, which now shows us that ray BD is an angle bisector of angle ABC. That means we could write a statement. We can now say that the measure of angle ABD is equal to the measure of angle DBC. As you recall, we know when we label angles, the second letter should be the vertex, and we need that kind of structure to be able to label carefully and accurately. That, of course, says that angle ABD is congruent, or the same, as angle DBC. All right, let's do that again, but this time we're going to do it with the obtuse angle here. Some people have some trouble. I also change the orientation of it, but it's the same construction. You'll just have to make a larger arc. Watch. Very easy to do. Metal point at the vertex. Choose a nice setting. That's a good setting for me. Draw an arc so that it intersects both sides of the angle. Notice how that was a little bit longer of an arc because it's obtuse. It's opened up more. Now, we need a good compass setting because it looks like we have to make it a little bit bigger. So, metal point on the intersection of the arc and side DE. Must keep the same setting, excuse me. Place the metal point at the intersection of the arc and side FE. And if you notice, we now get a point of intersection that we can use as reference to construct our angle bisector. So we get our straight edge, line up our intersection point between the two arcs, and the vertex, draw our ray. And yet again, we've established congruency. I'm going to use hash marks this time, which acknowledges the fact that I have congruent angles now. I've bisected angle DEF. I'm going to use letter H out here. I'm going to skip G. And so therefore I can write the following statement. I can now see that angle DEH is congruent to angle HEF. All from this one angle bisector there. So, it's pretty easy construction. You'll need to practice it. And for my last construction, it's just an extra one. I want you to construct an equilateral triangle. And by doing so, you'll be able to construct 60 degrees exactly. So it's a very simple construction. Here we go. First off, draw a segment. Not too big, not too small, just so you could use it. Easy enough. Get your compass. Using your compass, I want you to make sure you now want to duplicate this side. So, metal point on one of the endpoints, pencil point on the other, just as the same construction when we duplicated a line segment. Now, do not change the location of your compass. Now draw an arc. About a quarter of a circle. Now, very important, do not change the setting. Place the metal point on the other endpoint and repeat that arc. About a quarter of a circle. When you do that, you get another point of intersection. That point is a point of reference I'm going to use with my straight edge and connect it to each of the endpoints of the segment that I started with. When I connect with two sides, I'm sure you can tell, I've now constructed a triangle. And what I did was I duplicated the original side with the other two sides, and now I have an equilateral triangle. By doing that, I have also established a measure of 60 degrees. And not just here. I've established 60 degrees at every vertex. Now, what I want you to try to do is come up with a strategy to construct 15 degrees from this construction. That'll be your extension problem that we'll look at in class, and some others. So good luck reviewing and practicing your constructions.